Hello, everybody. We're about to begin right now. Welcome to the Shell Bitumen Paving Forward webinar series. We hope you have all been very well. This is the second installation of a series of engagements we have designed with you, our partners in mind. My name is Priyanka Krishnamurthy, and I'm the Global Brand and Communications Manager for Shell Bitumen. Before I hand over the floor to our panelists, let me just run through some of the housekeeping details for today's webinar. Safety is Shell's #1 priority. So we do ask you to please make sure that you're joining in from a safe place. You can hear the alarm and you are aware of the evacuation procedure in the event of an emergency. If you are joining from home, please make sure that the stove is turned off or attended to and that your exit walkway is clear. Just a quick reminder as well, we will not be discussing any commercial sensitive information in today's discussion, nor comment on specific customers or competitors. Please note that today's session is being recorded for our own use. You will notice that all attendees are automatically muted when joining. This is to minimize interruptions. However, throughout today's session, we do encourage you to submit your questions using the Q&A function available within the platform. This will enable the panelists to view and answer as many questions as they are able to within this 1 hour. To do this, you will need to click the options button. At the bottom of your screen, you'll see 3 dots. 1A, and tap the Q&A icon, that's 1B, until it turns blue. You will then see the Q&A panel box appear on the right-hand side, that is 1C. You can then enter your questions and click send. If you do need any help during the session, please do use the chat function to send a direct message to us. Click the chat button, which is 2A. The chat panel box will appear on the right-hand side, which is 2B, and then enter your questions and submit send. We will also be using a poll function during today's session to gather your inputs. Any submissions you make will be anonymous. When the poll opens, it will appear on the right-hand side, panel 3A. So let's try taking a poll now. It's always good to see where everybody is from, so let's kickstart that. You will see a poll on your right-hand side right now. Thanks for that. It's always good to see a good mix of people from different parts of the world, and we're very, very happy to have you today. So just a quick overview of our today's agenda. We will have a quick welcome and introduction, and then we'll go into a market insight specifically for our Asia and China, and then we'll kickstart the Q&A with our Shell Bitumen Global Technical Specialist. Without further delay, I would like to invite Professor John Reed, our General Manager of Shell Specialties Technology, to help set the scene for us on the topic of extending the longevity of roads. John is certainly no stranger to the bitumen industry and many of you. He first joined Shell over 20 years ago and has been at the forefront of developing innovative bitumen products ever since. John is also the man behind a very detailed Shell Bitumen Handbook, which is now into its 6th edition. John, over to you, please.
Thanks, Priyanka. And hi, everybody. And for those of you that attended the first in the webinar series, welcome back. And to everybody else, welcome. And I hope you really enjoy this event and want to attend the rest of the series. In this first webcast, which was in the first webcast, which was an Ask Us Anything session, everybody clearly indicated that you wanted to discuss more about today's particular topics of maintenance and durability, or in other words, making roads last longer. And so here we are today. In addition, we've decided to make the second webinar a little more interactive, as all the questions in the first webinars were sent before the event. This time, you get to ask your questions live, and hopefully we'll be able to give you some good answers. On top of this, we also want to celebrate Shell Bitumen's first 100 years in the industry. And to this end, I'm just going to take a few minutes to run through some of our achievements over this period. So this all began in 1920. In actual fact, it began in 1919 at Shellhaven Refinery in the UK, when we first ever produced some bitumen. But then during the end of 1919, we scaled up, and in 1920, we started first proper commercial production of bitumen. We have been producing bitumen ever since, so 100 years of continuous production. Taking a step forward in a decade, in 1937, FRAS, working in our laboratories in Amsterdam, known by some of you as KSLA, developed the cold bending test for bitumen, which is still in use today. Everybody refers to it as the FRAS test, and it was the first indicator of the cold temperature performance of bitumen. Then in 1949, we produced the first edition of the Shell Bitumen Handbook. Sorry, is somebody trying to get hold of me? Can you hear me okay? Priyanka, can I just check?
Yes, John, loud and clear.
Oh, sorry. Sorry, there was lots of pinging noises going on, and I wasn't sure whether or not somebody was trying to speak to me. So in 1949, we actually produced the first edition of the Shell Bitumen Handbook that Priyanka mentioned, which was actually then a pamphlet of just a few pages long, which has now blossomed into the 6th edition of the Shell Bitumen Handbook, which numbers nearly 800 pages. And I'm currently considering whether I and the team are going to start writing the 7th edition in the coming years. So, listen out for that. Then moving forward another decade, in 1954, a very, very important piece of work was done by Van der Pol. He developed the Van der Pol's nomograph, which is, still used today, and was the first demonstration of the connection between stiffness, time, and temperature when loading a bitumen sample. From this nomograph and the original work that was done by Pfeiffer and Dormal in 1936, we developed the bitumen test data chart, which is something that many people still use today to calculate equiviscous temperatures of bitumen, and in particular the mixing and compaction temperatures that we use on our plants and on our paving. One small interesting point of note, Van der Pol became very, very famous, world famous, because of his nomograph, but in actual fact, he was a lubricants person, and he only worked in bitumen for 2 years. And in those 2 years, he produced that fantastic piece of work. So it was quite exceptional. And then building upon all of that work around measuring performance of bitumen, in 1963, Shell developed the first analytical pavement design tools in SPDM, so the Shell Pavement Design Method, BZAR, and BANS, which are still in use today and form the basis of many design methodologies around the world. 1973, and I'm just picking out some of the red ones here, not going to go through all of this. We had the first documented full-scale trials of SBS modified bitumen. Again, a technology that is in use today and in fact is growing at perhaps the fastest ever rate. And I'm sure that's something that we will pick up and talk about later on in the call. But not only did Shell develop the first polymer modified bitumen, we also developed the polymer that went into that. So the SBS that went into the bitumen was developed by Shell. And then 1985, we patented Mexalt-C. That was a development from the original synthetic pigmentable binder that we developed, that was then known as Colorant, and that was back in 1968. And Mexalt-C has gone from strength to strength. We now have polymer modified versions of it, low temperature versions of it, trying to blend the aesthetics of the road network in with the surroundings is becoming ever more important. And demarking areas on the road, whether it's for pedestrians, for cyclists, for buses, heavy goods vehicles, normal cars, is becoming ever more important as our roads become ever more congested. Again, moving forward another decade, in 1998, we developed Clarifelt RC. RC stands for recycling, which was a means to be able to recycle a PMB modified asphalt back into a PMB modified asphalt. So this was the first real example of being truly circular. If you recycle modified material and it goes back into just a conventional material, then actually you're losing value. And that's not truly circular. It may be, from a sustainability standpoint, it's better than taking it to waste, but not truly circular. When you're truly circular, you recycle things back into the same product as they came out of, or even upcycle them so that they go back into a higher application. Then 2003, based upon the early work that we'd undertaken in the 90s into WAM foam, so that was warm asphalt mixture and a foaming technology. We developed our low temperature binders, a whole different range of those, enabling temperature reductions of up to 30 to 40 degrees centigrade. Very particularly important in terms of cost because of reduced fuel usage, now increasingly important because of sustainability, because less fuel usage means less emissions to atmosphere, less CO2. And then if I come fully up to date, in 2018, we've recently launched Shell Bitumen Fresh Air, helping the industry reduce its impact on air quality during the mixing and paving process by up to 40% in terms of NOx, SOx, carbon monoxide, VOCs, PM10, so particulate matters, 10 microns, and PM2.5 micron particulates. And so, I think that this shows that Shell has been at the forefront of technology throughout its 100 years, in the industry, and we continue to develop and to innovate. And maybe we'll come on to a little bit of that during the course of the rest of this call. Perhaps I can have the next slide, please, Priyanka. And so, talking a little bit about this series of webinars that we're running. Historically, we, as is the case for many of you that are on the call, have attended conferences, presented papers, given keynote speeches, run customer days, etc., in order to communicate with the industry. However, this year, things have changed with this awful pandemic. And so we're now trying new digital channels to stay connected to our customers through meaningful exchanges, to try and embrace more digital channels, which is now rapidly becoming the new norm, and to provide a channel for interactive discussions within the industry. And hopefully, we will make this very interactive today. And so on this basis, if you do have any feedback for us that will allow us to improve this series, we'd be delighted to hear from, whatever you have to say. So, on to today's subject matter of how to make roads last longer. What we want are the wonderful long-lasting roads that are shown in the nice picture on the left-hand side, and to try to avoid the potholes and the distress shown on the right-hand side. When we talk to many of you and your colleagues all around the world, are becoming just more and more prevalent. And to this end, let me just explain something about the theory of interspatial repeatability. Now, I did touch on this in the last call, but I did want to take this opportunity because it's very pertinent to the subject matter. When we're repairing potholes, what very often happens is that the potholes recur. 6 months after you filled them, either the material comes out or they just redeform, and the same pothole occurs again. And a lot of the time, that hasn't got anything to do with poor material. It's not due to poor workmanship in terms of the potholes. It's not that they haven't been filled properly and done properly. It's because we haven't actually cured the problem that caused the pothole in the first place. And what I mean by this is that very often the pothole is not in itself the problem. It's an event, maybe 100 yards, 100 meters further back down the road, where the lorries, particularly the heavy goods vehicles, they hit the event. That event might be a loose gully grate. It might be a deformed piece of ironwork. It might be just a bump in the road. But that bump in the road causes the suspension on the vehicles to go down and then to come up as it's supposed to do. But then it tends to hit down with a peak impact. Now, we've measured those peak impacts, and those peak loadings, they are anything up to 3 times the initial or the static loading of the vehicle. Now, it's also true to say that we've measured the body bounce or the frequency of body bounce of all sorts of different heavy goods vehicles, and they all tend to bounce at about the same frequency, about 3 hertz. Okay, which means that as all the vehicles tend to be traveling at the same speed, their body bounce is all at about the same frequency. They hit the same event. It means that they impact with this peak loading at the same point on the pavement, 100 yards ahead or whatever it might happen to be, time after time after time. Now, Jayan in a little while will talk about a little bit about pavement design. But if you believe in the fourth power law, which says that you take a standard axle and you raise it to the power of 4 to see the impact of any loading. If you're tripling the peak loading, so you've got 3 times the normal loading, and you raise 3 times to the power 4, you have 81 times the loading for that one vehicle on that spot on the pavement. And that's happening time after time after time. So the reason I tell you this is because we often get asked a lot on that. How can we, repair our roads better? How can we make them last longer? How can we stop the potholes recurring? And my answer very often is, go back and check your pavement. Look for the event further back down the road that caused the problem and cure that. If you cure that and then repair your pothole, more than likely it will last an awful lot longer than you're typically used to. So that was just a little piece that I wanted to talk around in terms of maintenance and durability of roads. And so perhaps the next slide, please, Priyanka. And so if I could just introduce my 2 colleagues that you can see on the video. So I have Jayan Vasudevan and Yan Hui, who will both be presenting some solutions from their respective markets and answering your questions as we go forward. So Jayan is our technology manager for Asia, looking after all new product introduction, technical service to our customers, product lifecycle management of all of our products, and also being a member of the business leadership team for the region. In addition, Jayan is just embarking on his PhD, which we are sponsoring to complete, looking into the use of non-segregated plastic waste in pavements. So that will be a very interesting piece of research going forward. And Yan Hui is our technology manager for China, which is our fastest growing region. And she has all the same roles as Jayan, and is also at this point in time busily rebuilding her team after having moved our laboratory from Shanghai to Zhenjiang, near one of our plants in China, and is also expanding the team to look after this key market. And Jayan is going to host the rest of this session. So Jayan, over to you. Jayan, I think you're on mute.
Thanks, John.
Okay, perfect.
Okay, Priyanka, can I have the next slide, please? Well, long-lasting pavement or pavement durability is the topic that we will be covering in this session today, as John mentioned earlier. And you might have come across different terminology for long-lasting pavement. Somebody calls it as a durable pavement, some call it as a perpetual pavement, and so on. So when we're looking at the fundamental, how do we create such kind of pavement? And we have to look it from multiple angles, multiple dimensions that we have to consider when we are talking about building a long-lasting or maintaining a long-lasting pavement. The first most important parameter, as always, is the material and how do we select the material. So the asphalt mixture design, that it is being used for that particular situation or particular project, has to be meeting certain requirement that is fit for purpose. Many times it is considered that we are just looking into the specification, and some of the time that we do understand that we do notice that the specification put forward might not be fit for purpose at that particular need of the project. And when we are talking about the material that it is required, we have to look into the overall material, not only the binder, but also the aggregate. Aggregate, as you know, that it constitutes higher amount percentage of the asphalt mixture as compared to the binder, which is much lesser. But binder play a crucial role in order to ensure that the material is intact in place. Thus, there is a lot of emphasis and being built lately on the how do we select binder that it is going to fit for certain application. So if you look into the super pave method, for example, it is looking from the aspect of the climatic condition as well as the traffic loading. They are evolving specification that it is coming into the market and always looking for what is the advancement that it is needed in order to achieve the material that it is required to be used for the long-lasting pavement. Having a material that it is superior doesn't warrant that the material is going to be in good condition on the road. So construction practice, how do we construct the road? And this is an element that we have to be taking into more concern on. That we have to look from the perspective of the contractors as well as the road owner that own the road and as the road user. So we have to look from an angle where this construction has to be done properly with the proper construction technique, as well as ensuring that the enforcement or the quality control during construction is being done properly. While talking about the construction, and as John mentioned earlier, we have to look into the maintenance of the road as well. So pothole is one of the examples that John has shown earlier that it is coming up in the road. We have to really identify how this damage mechanism is occurring on the road. We have to really understand whether this pavement been built in a proper shape and form. And over a period of service life, we will see the settlement taking place and bumpiness on the road, which is causing this damage that it is coming on the road. So we have, when we are building the road, we have to plan for the preventive maintenance and rehabilitation of the road itself. So we have to look into what are the cycle of overlays and inlays that need to be built in order to ensure that the road is lasting longer. We also need to look into how is the load being dissipated into the pavement. We know that in a simple mathematical technique, we say that when you are having a stiffer mixture, we can reduce the thickness. But we have to look into the overall pavement design, the overall thickness of the pavement. Where is the distribution of the stresses in the pavement layer itself, especially at the joints, at the interlayers between the layers. And sometimes, especially when we are reducing the thickness of the top layer, and what we oftenly find is it is causing a tension on the top at the pavement entire contact area that it is causing top-down cracking. And this is a increasing phenomena that we are looking at current point of time. And when we are considering to build a road that it is need to be lasting longer, we have to look into the holistic view of how is the stresses being distributed within the pavement layers. So the other element that we will be looking a lot is the materials that are being used for the construction. As the road being there for a long period of time, we have seen that a lot of appetite to increase the RAP usage or the recycled asphalt pavement usage. Priyanka, can I get the next slide, please? And if we are talking about circularity or the sustainability, we often see that asphalt pavement is one of the elements that it is highly circular and highly recycled. And we do see that in recent days, in many of the developed countries, the usage of recycled asphalt pavement is going higher and higher. Even you can see that there are technology being built to enable that a higher percentage of RAP that can be introduced into the asphalt mixture. When we are introducing higher percentage of RAP, higher meaning that more than 20 or 25% of RAP into the asphalt mixture, basically you need to have some changes in the hardware as well as the material selection or additive that you will use. In putting in a more friendly term, I would say that if you're looking at hydrocarbon material, it is going to be going through aging mechanism, similar to human beings, similar to us. When if we are looking at ourselves and then we are aging as we grow older, as we go further, and something that we could do at our younger age, we find it very hard to do it now, especially for me, and and also that we do see that these are aging mechanisms that taking place. And there are many corrective measures that we can take. For example, when human age, you can see that people opt for cosmetics like putting a foundation and then the wrinkles is gone. Some goes for a little bit expensive solution like putting a Botox or strengthen the skins, and some goes for the fundamentals, looking at building the strengths. They're looking at the food, they're looking at the exercise, and they look much younger compared to their age. And similarly, on the road pavement, you do have many, many options. You have options that can just treat the surface, make it shiny and nice, rejuvenate on the surface alone. But fundamentally, we have technology to look into how does the combination of additives or other material that we are putting in to enhance or rejuvenate back the binder that's being used, because it is going to constitute how durable is the road that we are going to build and last for a longer period of time. With that, I will hand over to my colleague Yan Hui for the following sessions.
Okay, thank you, Jayan. Good afternoon, everyone. I'm very happy to share with you some typical pavement maintenance technology in China. Believe most of you are very familiar with this curve. It's the Pavement Serviceability Index, which we call PSI, versus service years. From this picture, we can find that in the different maintenance technology can be implemented in different stage. When the PSI is still high, we can choose cold treatment like fog seal, chip seal, slurry seal to do the preventive maintenance. But along with the drop of PSI, we may need to consider microsurfacing, NovaChip, and Strata to act as both preventive and rehabilitation solutions. So first, I would like to talk some about microsurfacing. At the very early stage, we can choose microsurfacing to do the preventive maintenance. So next, please, Priyanka. Yeah. So microsurfacing system has been widely used in China as preventive maintenance and rehabilitation solutions to solve minor problems like raveling, rotting, surface oxidation, and also can improve surface texture with quick traffic return. So compared to other surfacing treatment technology, it's a very thin emulsion cold mixed overlays with very competitive cost. But it leads high quality fine aggregates to mix with polymer modified emulsion and be placed with special machine. It is not only has high requirement on aggregates and the emulsion quality, but also has very high requirement on the working experience of paver operator. So it can prolong the road service year to around 2 to 6 years if we can have good control in both product quality and well-organized construction. In recent years, another surfacing treatment technology, NovaChip, has also been developed and well accepted by China customers. NovaChip is a hot mix asphalt surface treatment with a single pass system. It's around 1.5 to 2.5 centimeters thick. If you're facing the challenges of noisy pavement, overhead clearance, backspray visibility, or loss of macro texture, even the challenge of long construction delays, NovaChip will be a good choice. It protects pavement, including both special designed emulsions and also PNB mixtures. We call the emulsions NovaBond, which can seal salt water and super bonding with surface layer. And the networked polymer modified bitumen, NovaBinder, can improve the adhesion, less drain down, and provide better cracking resistance. The special designed hot mixture use gap graded aggregates and can improve macro texture and reducing noise. Also can make the road more durable. It can even keep good cracking ceilings up to 10 years. The NovaChip system needs a unique machine called NovaPaver to do the pavement. This machine can spray the emulsions and paving the thin hot mixture at the same time. It's a faster construction system to reduce users' delay and can do light construction. So besides microsurfacing and NovaChip, I would also like to share with you one special technology called Strata. Strata is a reflective crack relief system, special designed for PCC reflective cracking. The hot mixture contains fine aggregate with very high bitumen content. So it's a very soft and impermeable interlayer of around 2.5 centimeters thick. And here it needs overlay of hot mixture asphalt. It's a conventional construction and no need for special equipment. This technology is also widely used in China, especially for those expressways which need to change the color from white to black. So I mean to change the PCC to bitumen road. Yeah, the most advantage of this system is that because it's a very soft interlayer, it can significantly delay the reflective cracking, and also as an impermeable interlayer, it can protect pavement from moisture damage. So it can also obviously prolong the service life of the road. So these are the solutions I would want to share with you. So thank you, and back to Priyanka. Yeah.
Tianhui, maybe I'll pass it over to Jan for the Q&A.
Thanks, Priyanka. Priyanka, can I get the second poll question, please? Okay, participant, you can see the polling question at your end now. In your view, what is the biggest challenge faced in the effort to extend the longevity of roads? You can cast in your poll, please. Okay, thanks for your response. And Priyanka, can I get the pre-asked questions, please?
Sure, JN. Give me two. Oh, the polling is almost up. Okay, and these are the three questions.
Thank you. And please type in your questions in the question and answer session so that we can also have those questions being answered during the session. Okay.
I guess we do have one question here before we go into the questions that we have received before the session, Jen. From Satish Kumar, we have a, how do we say that a PMB is uniformly mixed? Can you suggest some quick screening methods?
Okay, thanks for the question, Satish. I think when you're talking about polymer modified binder, there are many type of additive they will be using, and depending on the type of additive, then the way that you can do the measurement can be different, and of course there are ways we can use, like for example, if the additive that you are using is fluorescing, you can also use a fluorescent microscope to see how well it is being dispersed in the binder. Or the crude way is just to do a storage stability test that can give you similar results to ensure that whether the distribution is being done properly and whether the material is storage stable or not, because most of the time you can disperse the additive into the binder, but if the compatibility is not there, then the tendency for the binder to be segregated with the additives is high. So this can be a screening method that can be easily used. And John, if I may ask you to add on if there is anything else.
No, I think you've answered the question perfectly, JN. They would have been the two methods that I would have responded with.
Thanks, John. So Priyanka, is there any more other questions in the list, because it's too long actually? I can't.
Actually, no, that's not a problem. So we do have some questions. So from Harish R, his question is, with all these new products, any idea when to introduce them to the Indonesian market?
Yeah, but Harish, it's a great question. Yeah, of course, we do have some of the product that we tried out in our Indonesian market, especially our polymer modified binder. In fact, this is the binder that we are applying in the Soekarno-Hatta Airport is also using our technology and modification that it is used for high durable material. And of course, the surface technology that introduced by Yan Hui is something that we have in our portfolio. And if there is a need, we can always make such kind of technology available for you, Paris. Yeah, I think that would be the question, the answer.
Okay, we have one more question from Liu Jia. What is the reflex technology shown in the presentation? Maybe Yan Hui, you want to take this?
Then I didn't see the question here. Which question?
The question is, what is the reflex technology shown in the presentation?
Okay.
If I may add in on that, Priyanka, I think in the presentation that Yan Hui has done, she was talking about the strata technology. And I believe that in that slide, we did mention about the reflects about the reducing the reflection cracking when we are having a high stiff material like a concrete pavement, and we are going to overlay that concrete pavement or the cement-treated base with the asphalt material. Then usage of strata will have a better impact for reducing the reflective cracking.
Yeah, so even this strata technology is designed for the cement concrete. It is also can be used in the bitumen pavement, and also has good effect for the reflective cracking.
Thank you both. We have one more question from Rayan. And his question is, when we think of sustainable pavements, of course, the RAP comes into picture. What is your experience regarding long-term performance of the pavement constructed with the RAP usage?
Okay, that's a very interesting question, Rayan. Maybe before I answer, maybe I'll ask John to take up this hard question first.
Yep, by all means. So indeed, the use of RAP has been prevalent for a long time, particularly in Europe, and now increasingly so in Asia and China. What we are starting to see now in Europe in particular is that we are now starting to recycle the already recycled pavements. So they're going through their second or sometimes their third level of recycling. So the experience on the first iteration of recycling, which really was on average including about 10% RAP going up to a maximum of 20% RAP, because it was in the early days, that has all worked incredibly successfully. Essentially, we were at that point in time just doing what I would call viscosity blending. So we were looking at how hard the bitumen was on the RAP. We were looking at what viscosity we wanted to achieve in the final pavement, and we were adding a certain amount of new binder, a softer binder, back into that material in order to be able to achieve that level of viscosity. And that worked very well on the first iteration. What we are now finding in our research, though, is that there is a level of oxygen uptake in the asphaltenes which becomes critical. So we often measure that particular level, and what we find is that if you allow the oxygen uptake to get to 5% in the asphaltenes within the RAP, then in actual fact you can't really recycle that as a binder any longer. It is essentially just black rock, and you just have to add back in conventional bitumen and assume that you get no contribution from the binder that's in the RAP. And so this then comes down to, looking at your material, looking at your pavements, and understanding at what stage the material is actually at, because really you want to always recycle before you get to 5% oxygen uptake. If you do that, then it allows you to keep recycling time after time and, making material truly circular, truly sustainable. If we leave our pavements too long, and we allow the oxygen uptake to get to 5% or beyond, then in truth, then we're not being truly circular. We're not really recycling the binder. We're only really recycling the aggregate, and we have to add back, full amounts of binder. Otherwise, we get premature failures. And so that's really our experience, is that you can recycle time and time again. It is very, very effective. Now we are seeing even, much, much higher levels of RAP by people adding second drums on their plants to be able to heat it separately so that it doesn't clog the screens and cause problems in the plant. And we are seeing levels of RAP, very typically up to 50%, sometimes as high as 70% in Holland in particular. We see many papers and many claims of what they call 100% recycling. With a small amount of binder being added, but that is questionable, in my honest view, in my engineering opinion. I think you do need some addition of new aggregate and some addition of new binder alongside the wrap. So, my personal view is that, 70% is about as high as we can go, and be assured that the pavements that we build will have longevity, and that we're not actually just really creating a legacy situation for other people to deal with in the future. So, Jayan, perhaps, I don't know if you want to add anything to that.
No, John, I guess you covered it very well, actually. So, and I hope that you have answered Rayan's for his question.
Well, thank you, gentlemen. We actually have a two-part question from John Cedric Chan. So the first portion says, what are the project limitations of using strata technology in preventing reflective cracks? And how can we check the quality of strata product prior to application?
Yeah, actually, we have a document to indicate how to use this kind of technology and what needs to do pre-deal with those diseases in the pavement. So if you have potential projects or very interested in this kind of technology, I think you can contact your local Shell technical support to get more documents. Yeah.
Oh, John Cedric has also put in another question. He said, in the Philippines, we use concrete pavement as a stabilized, durable layer. What are your recommendations in adapting SuperPave method of mixed design in designing the wearing/binder asphalt course of the roads?
Okay, well, that actually is a very, very interesting question, because when we look at what SuperPave has done in the US, what we've seen is that in the past, before early 90s, late 80s, what they were seeing in the US was a lot of rutting, so a lot of real deformation. And they bought SuperPave in and did all of the research, etc., stuff to get better binders, better mixtures, better designs. That was great. And what we have now seen since then is that SuperPave has essentially eradicated deformation of the pavements. But what it has done is created, a propensity for cracking in certain areas, particularly where they've got large differentials of temperature. And so, in some ways, the standard SuperPave design doesn't work so well on top of concrete pavements for the simple reason that it has a tendency to crack, and you already have essentially cracks in all concrete pavements because we build them in, unless it's continually reinforced. But if you are then rehabilitating it, then even if it's continually reinforced, it means that you've probably got cracks or spalling or some sort of degradation that's going to reflect through whatever layer you put on top. And so the adaptation, is that we want to have higher binder contents, modified binders, and probably slightly finer gradings, in order to be able to ensure that we don't create stiff mixtures that will have a propensity to crack or to allow the cracks to propagate through. And so that's how we would really have to adapt SuperPave in order to be able to lay it effectively over the top of concrete pavements. But again, what I would come back to is the technology that Yan Hui described in terms of strata. If you put that sort of stress-absorbing membrane interlayer, over the top of your concrete pavements, then it's incredibly effective at resisting all of those cracks coming through. And then you can lay standardized materials on top without being so concerned about the cracks in the lower layers. And so that would always be my advice, is to put a layer of strata in and then to construct on top.
Thank you, John. I guess I just want to say to everybody, we are getting quite a few questions, so we do apologize if we can't cover all of them today. But what we can do is, after the session, we will have a document with the responses, and then the responses will be shared with your Shell Bitumen representative, so you can get in touch with them if your question is not covered in today's session. So we have 10 more minutes. How about a few more questions? We have one question from Veera Raghavan. His question is, the preventive maintenance treatment can be applied to pavement in good condition. How to quantify and define good condition?
Okay, let me start first, and then I'll hand over to John to add on. In my opinion, that when we are designing the pavement itself, we are going to design the pavement for a certain period of time. And of course, saying the design philosophy is one, but in the actual, then we are subjected to the material that has been selected as well as the construction that has taken place. And not only these two parameters, but we also need to look into the other parameters such as the drainage capacity and also the traffic loading and overloading condition on the road. So it might not follow the intended damage mechanism. So it would be always ideal to have a screening or pavement management that being done on the sector of road that we can plan our maintenance cycle. But it would be ideal to have a GPR type of vehicle in order for us to screen the road network. But having a data available on the condition of the road will give us a better idea when it is how do we introduce the preventive maintenance before it goes into the damage. And easily identify is when we are already seeing such development of micro cracks and so on. This is an early indication that the pavement is starting to deteriorate. John, over to you, John.
Yeah, I mean, this is actually, whilst it's a very good question, and thank you for it, it's very difficult to answer definitively because every country has different requirements, different standards, different ways of looking at their pavements. Some countries will look at the polishing of the aggregate because skid resistance tends to fall off before you start to get to structural deformation or structural cracking. Some countries are not so concerned about skid resistance, and they're looking at the structural quality of the road, and so they're looking at the onset of cracking or a certain level of deformation. In the UK, for example, if you get to 10 millimeters of deformation in a road, that is defined as getting to critical. So you really need to act at that point if you want to be applying preventative maintenance. If you allow it to go beyond that, then you start to get towards failure, which is determined at 20 millimeters of deformation, or alternatively 10% of cracking on the pavement surface. And so, because every location has a different requirement, it has different traffic, different climatic conditions, I think that this is something which needs to be determined for this specific location, and that's certainly something you can discuss with your local Shell technical representative, and then begin to look at what would be the point for your particular conditions, your particular location. That would determine when you need to start to apply preventative maintenance. Because, and to be honest with you, when we talk about how do you make roads last longer, I mean, that is the answer. You design them to last as long as you possibly can. And one of the things we haven't really got to it in terms of answering any questions, but I do want to just touch on it, and that's compaction. So when you're building your structure, whatever it is, compaction is absolutely critical. If you don't get the compaction right, and really to the right level, then you don't want to overcompact it. don't want to fill the voids with bitumen, because if you do that, then it will start to deform. But you don't want to under-compact it, because then you get secondary compaction and it will deform. So compaction becomes critical in all of this. And, you know, and I'd like to give a shout out to a lot of the work that's been done in the US with intelligent compaction. You know, that would be definitely something that I would advise everybody to look into. You know, so they now have, you know, the rollers controlled by GPS positioning, and so that you can get your rolling plan together. You can ensure that every part of the pavement has a sufficient number of passes of the roller. You can also monitor in real time the actual density of the surface, and therefore you can ensure that your compaction level is exactly correct. You know, and one of the things they've done in the US along that line is given bonus payments to contractors who compact their structures well, but also penalise contractors who haven't compacted their pavements properly and in accordance with the specification. You know, and so that acts as a real incentive to make sure that we're really constructing these structures correctly in the first place. You know, and that. You know, so that's one thing you can do that doesn't really cost a huge amount of money, but it will save an awful lot of money. You can also, you know, put stiffer binders in the lower layers when you're constructing your pavement in the first place, and that will also allow you to have longer pavements. But you know, they will still deteriorate, and if you always apply preventative maintenance, it is cheaper to put in preventative maintenance than it is to have to reconstruct. But unfortunately, what we always do is say that that's somebody else's problem, because often it's a political cycle that determines when you're going to do any work, which is really wrong for the pavements, as we all know. What we really want to do is to apply preventative maintenance at the point at which we start to get to critical rather than to failure. And that allows us to keep the life of the pavement up to where we want it to be, and as a consequence, then get the maximum possible performance out of your pavement. So I guess that's probably what I want to add, Jan.
Thank you, gentlemen. Maybe we have time for just one last question. One question from James Purdy. Any suggestion on methods of quality control for pavement, either in situ or laboratory?
Can you repeat the question, please, Priyanka?
Sure, Jayan. Any suggestions on methods of quality control for pavement, either in situ or laboratory?
Quality control, again, I mean, these are the things that John has already mentioned earlier. It's one of the things that we do normally on the quality control and on site during construction is the compaction, level of compaction being monitored during the construction, either using infrared method or using nuclear density or non-nuclear density measurements that are being utilized. And during the design or in the laboratory, of course, we can check on how is the mixture performance, and this is the pre-work, I would say. It is just to ensure that whatever has been done in the design phase has been followed during the mixture production and laying phase on the actual. John, if you want to add in.
No, I think that's fine, Jayan. I did just want to make one point, because we're coming to the head, and Priyanka mentioned this, but you know, there have been so many questions that we haven't got to, so we can only apologise for that. And what exactly as Priyanka says, we will answer all of those questions. We will write answers to them, and then we will post that document on our Centenary website, which Priyanka will give you the details of, so that you can go in and see the answers. And then if you want to take up any further discussion with us, because some of them are quite detailed and very specific questions, you know, then we're very happy to do so.
Thank you, John. That does flow me very nicely into saying, we have come to the end of today's session. So we do thank you all for your participation, and we do apologize that we couldn't cover all the questions. But it's also just a gentle reminder to please complete the post-event survey to give us your feedback. This will definitely help us curate more topics you may be interested in. Also, if you enjoyed today's webinar, do look out for more updates and invitations to our future sessions. And you can go there and you can look at it at www.shell.com/shellbitumen100. We look forward to seeing you again at all our future events. Goodbye, and we hope you have a wonderful day. Thank you, everybody. Thank you, Huyen, Joanne,
Bye-bye.
John.
Thank you. Bye.